Good afternoon, dear students. How are you? Okay, let's start our class. Today's our class geometrical probability. Okay, it's from third chapter mathematics of chance. Now I am taking geometrical probability. Okay, let's go to the questions. Calculate in each the probability of a dot put without looking to be within the green part. Okay, listen carefully. Read the question. Calculate in each. Some figure will give to you. Okay, calculate the probability of a dot put without looking to be within the green part. Okay, I am giving the question this figure. I am putting a dot without looking to that sheet. What is the probability of it being in green part? That is the question. At first, let's check the figure. That is a square got by joining the midpoint of a big square. It's a square. That green part is a square that joining the midpoint of a big square. Midpoint of a that yellow, that big square. Okay. Then do you know the equation of finding probability to be within the green part is equal to probability to be within the green part is equal to area of green part divided by area of total part. You have to study this one. Probability to be within the green part is equal to area of green part, area of shaded part divided by area of total part. You have to study that. Then how can find the area of green part? So to find the area of that green part, we have to find the sides of that square. Let's take this as A. Okay, this I am taking this side from center to the end. I am taking A. Now this also will be A. What is the reason? This point is the midpoint of the big square. So if this is A, this also will be A. Then what is the length of that big square? That will be 2A. 2A. So we got the length of big square. Now we want to find the length of small square. This can you find? It's a right triangle. This one, it's a right triangle. 45 90 right triangle. Can you say the ratio of the sides of the right triangle? 45 90. That you have to study. X is to x root 2. X is to x root 2. That ratio you have to study. So this length will be here A, here A, and here also A. So this will be A root 2. A root 2. If here is 2 and here also 2, this will be 2 root 2. 3 root 2. 4 root 2. X root 2. That is the ratio of 45 90 right triangles. Okay, now let's do area of green part. Area of green part, that will be A root 2 square. A root 2 is the side of that square. So area of the green area of that square is A root 2 whole square divided by area of big square, that is 2A is the side, so 2A whole square. Ready? Then can you do A root 2 square? What is the answer? That is A square into 2. A square into 2. A square, that is A square root 2 square is 2 divided by 2A whole square. What is 2A whole square? That is 4A square. Now let's cut A square and A square. What is remaining there? 2 by 4. That 2 by 4 you may reduce as 1 by 2. Ready? There is a common factor is there. 2. How many 2's are there in 2? That is 1. How many 2's are there in 4? That is 2. So final answer is 1 by 2. Okay, let's draw 2 line. Ready? Let's go to the next question. Okay, this question you may do a simple method. That also I am writing. This question I am doing in a simple method. At first I am writing this equation. Probability to be within the green part is equal to area of green part divided by area of shaded total part. Then I am joining a line from here to here and to here. Now there is some triangles with the equal areas. Okay. Then what is the area of the green part? There is one triangle, 2, 3, 4. That is 4 triangles. That is the area of green part. Then what is the area of the total part? In total, how many triangles? 1, 2, 3, 4, 5, 6, 7, 8. 8 triangles divided by 8 triangles. Let's cut triangles and triangles. So 4 by 8. 4 by 8. We can reduce that 4 by 8. That is equal to 1 by 2. In some case we can do like this way. If we can cut that equal area triangles or equal area square, that type of question you may do like this way also, no problem. Okay, let's go to the next question. This is the final answer. Let's go to the next question. This one. In this type of question, we can't cut it into equal triangles or equal square or equal circles. So we have to find the area of the square and area of the circle. At first, let's explain this figure. A square with all vertices on a circle. Here a square is there and all vertices of the square is on the circle, and probability to be within the green part is equal to area of green part divided by area of total part. You have to study that. Now how can find the area of green part, area of that square? That is given, the two side is given the 2, so area of the green part will be 2 square, that is equal to 4. Okay, let's check. Now how can calculate the area of the circle? For finding the area of the circle, we have to find the radius. How can find its radius? This is 2 centimeter and this also 2 centimeter. I am drawing a line from here to there. How much will be that? I told you the ratio of 45, 45, 90 triangles is x is to x is to x root 2. That is 1 is to 1 is to 1 root 2. 2 is to 2 is to 2 root 2. 3 is to 3 is to 3 root 2. Now here this one 2 is to 2 is to this 2 root. Diameter is 2 root 2. Then how much will be the radius? Radius will be half of the diameter, that is 2 root 2 by 2, that is root 2. Radius root 2. Now let's do area of green part. I told you that is 2 square. Area of total part, that is circle. How can pi r squares? Area of the circle, pi r square. R is here root 2. So divided by pi into root 2 square. Pi into root 2 square. 2 square is equal to 4. Then pi root 2 square is equal to 2. Pi into 2. Ready? Now let's reduce that 4 and 2. We can cut with 2. How many 2's are in 4? That is 2. Then how many? Then pi you may write there. Then how many 2's are in? That is 1. So you may reduce that as like this way, 2 by pi. It is the final answer. Okay, let's do one more question. This one. In this case, Circle exactly